Hi, welcome back. In my last video I've shown you how to perform chi-square test. In this video I'm going to show you how to perform t-test. There are different types of t-test. In case if you would like to know what is t-test, just have to search for t-test Wikipedia. It is also known as students t-test, and there's a lot of information regarding what is t-test and what is the methodology behind this t-test. Usually the t-test is a parametric statistical hypothesis test, also known as students t-test. We need to make the hypothesis well before performing a t-test. In most of the cases the null hypothesis is standard, a default statement. We don't need to define the null hypothesis. It depends on the context in which we are trying to perform the t-test. I mean, the null hypothesis depends on the context in which we are trying to perform the t-test. This is actually the mathematical expression behind the t-test. The t is calculated by using a ratio, the difference between the sample mean to that of the population mean divided by the standard error, and the formula for the standard error is the standard deviation over the square root of sample size. So whenever we are performing the t-test using any software, that software will be computing this ratio, and that ratio will be converted to a p-value, and based on the p-value we are just going to take the inference that whether a particular assumption is true or not. Now coming back to the t-test, in R we have a very simple function, that is t-test, t dot test. So if you if you execute this help within parentheses inverted commas within inverted commas t dot test, then you will know the documentation, very minimal documentation for this, as how to perform the methodology, the methods behind the t-test and all. This is the syntax, and if you observe the syntax, we need to have a non-empty numeric vector of the data values. It is optional. You can either have one single data vector, or maybe a couple of data vectors, or maybe the data values or variables or data distributions, whatever it is. And we also have to, these are all optional actually. The alternatives, you have default kind of behavior. Suppose if you don't issue any argument for the alternative, default it will take greater, two-sided. Suppose you want to test for the greater, then we need to issue greater as a value for this parameter or argument. Then by default the mu value is 0, paired is false. In case if you if we would like to perform the paired sample t-test, then we need to convert this paired is equal to true. And there are a couple of other things. This arguments, you need to study what is t-test in order to know the options for these arguments. There are details, and these are the values, which means after performing the t-test, R will output all these values. There will be a statistic, there will be a parameter, there will be a p-value in that output. This is the example. Perhaps this is the most important thing for the beginner. Say here there is an example statement like t dot test open parenthesis and then 1 to 10 y is equal to c 7 to 20, something like this. You see here actually the colon operator is used in order to simulate the data vector, and here the C operator is used to simulate data. These are the simulated mechanisms were used to perform the t-test, and now this is an answer for that. And then you have can also, so this is another way of performing the t-test. We can with the context manager, something like that. There is a data set called sleep, and with sleep perform the t-test between the extra the group is equal to 1. something like this. Extra group is equal to true. This is the brackets within the extra. Um, anyway, I'm not going to talk about perform this way. I'll be showing you how to perform a sample data. Then we can also use the formula inside the t-test. Then it will give you the pairwise comparisons, just like in a regression fashion. Suppose if you have some categorical data just like an ordinal data, then we need to use a formula or something like this. It is up to the user. If you are interested, you can just copy each of the statements and paste inside your RStudio and then perform. Now I'm going to show you how to perform on this sample data. My data is here, so I'm going to perform t-test on each of these variables. The assumption is going to be like this. The null hypothesis for this, I'm going to test the mean difference between the age of sample 1 and the age particulars of the sample 2. So which means we are just going to, let me open my, don't know if I have the, so I have sample 1 age, sample 2 age, the age details of the two sample distributions, two different samples. And suppose if I assume that the age particulars, the mean values of the mean difference between these two samples, these two samples is not equal, that is going to be the alternative hypothesis. Like I have the sample 1, sorry, I have the sample 1 but age, I have the sample 2, and we have the age and age. Now whenever we are performing the t-test, so first let me explain you how to perform the one sample t-test. When we are performing the one sample t-test, we'll be using x bar minus 0 instead of mu and standard error. This is what is the formula for the one sample t-test. So the assumed mean by default is going to be 0. So now the null hypothesis obviously is going to be the difference between this, x bar is not significantly different from 0. That is going to be the null hypothesis is going to be x bar is equal to 0. Alternative hypothesis is going to be x bar is not equal to 0, which means there is some certain effect inside this sample. It is not actually 0. So null hypothesis, though you have some effect, which means though you are trying to prove that there is some effect in your sample, but in fact that effect is 0 kind of thing. So this is unbiased statement, this is biased statement. But in order to prove that we are not biased, we need to provide the evidence, and the evidence will be, after performing the t-test, we can show the evidence in the form of p-value. So p-value is very critical to interpret this the mean value in this sample. Now we need to, this is the data as I have, we need to get the data inside, so I call t data kind of thing. Now read CSV and file choose, and then press enter. You will get a window like this. Go to the folder or the directory where you have your data. Now here I have my data. Should change my data next time. So then, now let's see what is there here. So I have the same type sort of data. Think there's something went wrong. Sample behavior t-test CSV, two sample t-test. What is this data? Here t-test I have the same. So I did a mistake while saving this data. Two sample t-test. Yes. Now let me go back and do the same. This time let me see. So this is the nonsense with this. should automatically go to, should be able to remember the last action, t data. Yeah. So now let us perform the t-test on the very first variable, that is the age particulars of the sample 1, and here obviously the null hypothesis is going to be this one. The let's see the mean value of t data, and then I have okay, I'll go for indexing. This is the mean value for 50.86. So though we have some certain value, the valid mean value, when valid some certain mean value in our sample, but in fact this mean value could be 0. That is what is going to be. So which means the value which we are saying here is only a matter of sampling strategy. This may be biased. Actually the true value in the sample is 0 and it is not 50.86, something like that. Now if that is the, then we have to perform the t-test, and now t data, where do we have, this is the very first column. Now this is going to be one sample t-test, right? Mu, we have to give optional, the mu value should be 0. That is what is one sample t-test. TTest, it is not, there is no function called TTest. Now you see this is the output of the, now you got the t value, and for this degrees of freedom, because we have 15 data points, so 15 n minus 1 is 14. The p value is 0, very close to 0, 8.623 into 10 to the power of minus 10, which is very close to 0. We have a lot of evidence in support of alternative hypothesis that the t value is not equal to x bar value is not equal to 0. So we can reject the null hypothesis in favor of the alternative hypothesis, that we got a lot of evidence. The criteria is very simple. The more close we are to the, I disturbed my so the closer the value, suppose if you have a p value 0 here and here it is 1, the p value always, the probability space of the p value is between 0 to 1. Now there is a cutoff value which is 0.05. now the closer the p value to 0, we have evidence in support of alternative hypothesis. The closer the p value to 1, then we have evidence in support of the, it is not evidence actually, we can't we fail to reject the null hypothesis. Now here the p value is close to 0 here, so we are well below the threshold value, so we have evidence in support of the alternative hypothesis that the actual whatever the mean effect, I mean this is what is the effect, mean value that we are perceiving through this sample is not in fact 0, and this is a true value. So the sampling, there is no sampling error in our data kind of thing. Now if you want to go for the 2 sample t-test, it is something like this. Let me set up my whiteboard. I don't know, I disturbed somewhere and I'm not able to find the background. Okay, the 2 sample t-test, we have sample 1 here and we have sample 2 here, and there is x1 bar kind of thing, there is x2 bar. Now the null hypothesis is going to be the x1 bar, I am sorry, it is not is equal to, it is colon, x1 bar is equal to x2 bar, which means the difference between these two means is not statistically significant. Like the other way we can also mention x1 bar minus x2 bar is not equal to 0. So this is going to be sorry, this is going to is equal to 0. It's not equal to, is equal to 0. The difference is actually the 0. Now alternative hypothesis is going to be x1 bar minus x2 bar is equal to 0. So the difference between the means, I'm sorry, I think this is I'm confusing. I think x1 bar, actually the null hypothesis is equal to x1 bar minus x2 bar is equal to 0. Yes, This is the null hypothesis, because x1 bar is equal to x2 bar, which means this implies x1 bar minus x2 bar is equal to 0, and is not equal to 0 is going to be the alternative hypothesis. So this is going to be the t-test, two sample t-test. So it is very simple. We just have to issue same command, but here we come t data, and this time this is going to be 2, but we need to we don't need this new value. We just have to, that's plain statement. We don't need to worry about the rest of the arguments, two-sided or less or greater. I'm not going to complicate my. So t-test, t-data, this is variable 1 and variable 2, which means this is a variable 1. 1 stands for very first data variable column, 2 stands for the second column in the data set. So we are performing the t-test between these two samples, age particulars of the two different samples, and the first two columns are. When you press enter, you will get the t-value is 0.465, and for degrees of freedom 27.295. The p-value is, this is the t-value, so I don't know what I pronounced. This is the p-value. P-value is 0.64. So now this time we fail to reject the null hypothesis because the p-value is very close to 1. It is well beyond the threshold value, which is 0.05. So at 5% significance level, we fail to show the evidence in support of the alternative hypothesis. So we fail to reject the null hypothesis. So we are accepting the null hypothesis, which is x1 bar is equal to x2 bar. Now let's see what is. See here, you have the means. The first mean is 50.8667, and second mean is 48.33333. Now, though there is some certain difference, but that difference is not statistically significant. That is what is the null hypothesis. We fail to reject the null hypothesis. So though the age particulars of these two samples, age particulars were collected from two different samples, but both of them belongs to same population. So that is how we need to interpret the data. Okay, in the same fashion, we can also perform the two sample t-test here. And suppose you want to go for the paid kind of thing, you just have to, if you assume that they are paid sample, sometimes what happens is that these two sample variables might be paired. Same individuals, maybe the data are collected from the same individuals in two different times, or they may be same criteria, but there may be different individuals kind of thing. So if we imagine that this data is coming from the same individuals at two different points of time, then we can go for the paid sample. Same statement, but we just have to give paid is equal to true. Now let's see what's going to happen. Now we have the mean difference. This time it won't give you the same difference. It's not going to have the same t-test. You're not going to have the different but the way internally the p-value is calculated internally will be different, because that is just a matter of there is a particular concept called pooled variance. So this paid t-test is just going to compute the variance in a different fashion. The only difference is the way these two tests compute the t-test pooled variance, but rest of the particulars are the same. Here the t-value is 0.41367, and now degrees of freedom are different. If we say it is a paid, then it is going to be 15 minus 1. If we say it is to independent sample to test, then it is going to be 30 minus something like that. Minus, obviously it is going to be 2. Usually 30 minus 2, it is going to be 28. I don't know why it is 27.297. Maybe there may be a kind of a special formula for computing the degrees of freedom. Now the p-value is as close as the first one. P-value is 0.6854, which is well beyond the threshold value, far above the threshold, which is 0.05. At 5% significance level, we fail to reject the null hypothesis. So the difference is not statistically significant. So they are from the same individuals. When this data that we collected. This is, though we have two different data distributions, both of them belongs to same type of same individuals, or both of them belongs to, if this is the, say in this context we say both of these data vectors belongs to the same population, I mean samples belongs to same population, and in this context we try to interpret that the data belongs to same set of individuals, they are not from two different samples, kind of thing. So this is how we perform the t-test, and there are quite a, please be cautious that whenever we are performing the t-test we need to ensure that the data is continuous and it is also normally distributed. How do you know that it is normally distributed? So there is a histogram, you can go for hist t data now comma 1 and frec is equal to false. I usually plot the histogram by using density, not the, now you see here it is perfectly normal, and you can also overlay the lines and density t data 1. We can also use call, it's going to be red. Now I see you got the, so this is perfectly normal, if not perfect then close to normal distribution. So there is nothing, it should be normal distribution and the data should be continuous, it cannot be ordinal, nominal kind of thing. There are dozens and dozens of non-parametric hypothesis test in case if you are performing on any data which is not interval or ratio. Like if you are performing the t-test, if you want to perform the t-test over nominal data or ordinal data where the mean is not in action, either you have, which is not, I mean basic, if you are not able to prove that the underlying data distribution is not normally distributed, then you can go for the non-parametric test. There are quite a few tests you can so we'll try to talk that, I will try to talk about non-parametric hypothesis test in my next video. This is for this video. Thanks for watching this video. Stay tuned to the new content. If you like my video, please press like button and don't forget to subscribe to my video channel. Thanks once again.